Hello everyone. Today we're going to talk about linear and angular speed. So you'll notice we got some formulas here and we're going to try and talk about the difference between angular and linear speed. The main thing that you need to observe here is if you're talking about angular speed, what you're really talking about is some angle over time. It's not a distance over time, it's an angle over time. So these are going to be, our units are going to be something like radians a second. So we use, actually it's a lowercase omega. That's uppercase omega. That's a lowercase omega. So Greek letter, but I'll just say W. Uh, for the angular speed and for linear speed, we use V, which might actually be a N. I think that's a lowercase. It's like nu. It's not mu. It's nu, I think, but that's the V. So the difference between these two equations, look, they both have theta over time. But what the thing that is different about linear speed is you actually have to know the radius. So angular speed, you're just spinning around in circles. It doesn't matter if it's a humongous circle or if it's a tiny circle. With linear speed, it matters what the radius is. So that's kind of an important distinction. You're going to want to pay attention. If you see that you know about the radius, you're probably going to talk about a linear speed. If you don't know a radius, then you can't do linear speed, so it's probably angular speed. Let's see if we can work through a couple of these. This guy says it's rotating and he's spinning a yo-yo, so he's kind of spinning a yo-yo above his head like this, and we're trying to figure out the angular and linear speeds of this. So let's talk about, first of all, what we need. We need to know for angular speed, which we were saying that's W, we need to know theta over time. So theta is an angle in radians, and time is whatever unit they give us. So for theta, we first need to realize that there are 15 revolutions that we're going to spin. He spins it around 15 times, and each revolution is 2 pi radians. So our theta is 15 revolutions times 2 pi radians, which would be 15 times 2, that's 30 pi radians. If you spin around 15 times and each one is 2 pi radians, then your angle that you spun around is 30 pi radians. Okay, that's 15 full spins. So we know theta, and now our time is 15, no wait, what's our time? 10 seconds, 10 seconds. So our angular speed, W, would be 30 pi radians over 10 seconds. So this would be then 3 pi, and the units are radians per second. So 3 pi rad a second. 3 pi radians a second. Every 1 second, he does 3 pi radians, which means essentially he spins it all the way around and then half a revolution again, because pi is half revolution. So all the way around and then one more half every second. That's what we're saying his angular speed is. Now that doesn't matter if he has a humongous long rope, which would be going around really, really fast, or a really tiny one, which would be harder to do. This is angular speed. For linear speed, now we're going to pretty much do the same thing, but we're going to include the radius. So it's r theta over time. And now we know the radius here is 3 feet, so this is 3 feet. It's still going around 15 times, so your angle is still 30 pi, and the time is still 30 seconds. Now, if you'll remember, a radian is the angle formed by a length of radius on the outside. So when you say I want to take 30 pi radians and each one is 3 units, this unit now is a distance. This is a distance, and it is in whatever unit the radius is, feet. So this is feet per second, and if you multiply that out, you're going to get 90 divided by 10, which is 9 pi. That's feet per second. But when you're doing these problems, 9 pi isn't really something you were taught. Like, you wouldn't see that on your speedometer, essentially. So what I'm going to do now is actually figure out what that would be if it was a decimal. If it's a speed, I want to know what that actually is. So we're going to say 9 pi. Should be like 28. Look at that, 28.27. So we'll say 28.27 feet per second. So that's moving pretty quick. 28.27 feet per second. That is our linear speed. So angular speed, we're just saying how fast is it spinning around. And then for linear speed, we're saying like if you were to actually let this thing go, it would go at 28.27 feet per second. This is kind of a weird question. So what we're actually talking about is there's a winch that's pulling something up. The fact that it's a windmill blade doesn't really matter, but you have a winch that's pulling something up. So you have this item being pulled up. It is a windmill blade here, but when you think windmill blades, you think spinning around. This is just being pulled up. So we're going to first find our linear speed because it's saying what's the speed of the windmill blade? How fast is it getting pulled up towards the top of the crane? So for linear speed, we use r theta over time. So let's first figure out, do we know the radius? The radius is 2 feet. Nice, okay. So that would be 2 times. Theta, 8 revolutions. So remember, if it's 8 revolutions, then theta would be 2 pi for every one of those. 2 pi times 8 is 16 pi. So this is 16 pi over, and the time is 15 seconds. Now again, this is a distance, so that's feet, and this is a time, so we're talking feet per second. So this is 32 pi over 15, which I'm going to actually get the decimal for. So 32 pi, that's not a 2, 32 pi over 15, and I get 6.7 V equals 6.7, and that's feet per second. Okay, so we're kind of just using a formula, but this can be a little intimidating. This is like some physics stuff. Let's try maybe one more kind of like this. This says a potter's wheel with a radius of 10 inches spins at 200 RPMs. So 200 RPMs, what's maybe important you know is that is an angular speed. I'm giving you an angular speed. And that's going to be in, I'm going to tell you I want this in radians per second. And then linear speed I want to do in inches a second. I didn't give you units, so let's do those too. But if it says 200 revolutions per minute, you're going to go around 200 revolutions. Each one of those is 2 pi, so that'd be 400 pi radians. If you go around 200 times, that's 400 pi radians. So if I say what is the angular speed, it's 400 pi radians over 1 minute, which is 60 seconds. If I wanted 60 seconds, then I would do 400 pi divided by 60, which that will reduce to, these are both multiples of 20, be 20 pi over 3. And since it's an angular speed, I want to leave it in radians, radians per second. Because remember, 20 pi makes sense. If you're talking about radians, I'm saying 10 revolutions. 10 revolutions every 3 seconds is essentially what we're saying. Now I have my angular speed. Let's find the linear speed words. R theta over time. So now the only difference is I have 10 times 400 pi over 60 seconds. So this is now my units are inches per second. Now I could have done 1 minute, but I know I want it in inches per second, so I'm going to do 60 seconds. Now again, linear speed, I'm actually going to multiply out. So this is going to be 10 times 400 pi. Let me see if I can bring this to the front. 10 times 400 pi divided by 60. And that is 2,094. Wait, I think I got too many zeros. Yeah, it's 400 pi. It seems especially fast. Okay, so it's 10 times 400 pi divided by 60. Yeah, just move the decimal. 209.44. 209.44. And this is inches per second. So that's moving. 200 inches per second is getting that. That's pretty quick. Okay, but you've seen when those potter wheels go around, they move pretty quick. Okay, now there are some practice problems here, and what I want you to do is pause the video and see if you can do them, and then hit resume and actually see if you did them right. But it's important that you give these a shot before I do them, because watching me doesn't accomplish anything. You need to put in the work, and you need to try it. So hit pause, try them, and then I'll go. And we're back. So let's see. Ceiling fan with 16 inches, rotates at 45 RPMs. Okay, fine. So what are we asked to find? We're going to find an angular speed in inches a minute. So W would be 45 RPMs. 45 revolutions is 90 pi radians because it's 2 pi for every time you go around. So this would be 90 pi radians, and that's RPMs, so that's 1 minute. So revolutions per minute. We're saying 90 pi radians per minute, so that's just 90 pi radians a minute. It's kind of already done for us. When they give you RPMs, we're just going to convert it to radians. So for B, it says find the linear speed. Okay, so we're going to do the same thing. R, the radius, is 16 times 90 pi. And we're still doing it. It's inches per minute because the radius is in inches. It's still 1 minute, though. So this is 16 times 90 pi inches, which is going to be a lot. So let's see, 16 times 90 pi, and then we're going to divide by, oh, we don't have to divide by anything. It's 1 minute. So 4,523.89. 4,523, ooh, that's too many. 0.89, and this is now inches per minute. 4,000 inches a minute. So the ceiling fan is going around quick. The tips of the blades are going at 4,500 inches per minute. So they're moving. Okay, next one, radial assault. Very similar. We're going to find the angular and the linear speed. So for the angular speed, we do theta over time. If it's 1,000 RPMs, you go around 1,000 times. That's 2,000 pi radians, because it's 2 pi radians for every time you go around. So 2,000 pi over, we want it radians per minute, so that's in radians. And if I just say it's RPM, so 1 minute. So this is 2,000 pi radians a minute. 2,000 pi radians a minute, okay? If they give you RPMs, they're giving you the angular speed. Like I said, we're just converting it into radians. For linear speed, multiply by the radius. The radius is 6, so now we're in inches. So 6 times 2,000 pi over, still 1 minute. Although, oh, wait a minute. We want our answer in feet per second. So let's make that 60 seconds. Tricky, tricky. But our units in the top are inches. So it says it wants feet per second? Okay. We'll convert the inches to feet in a second. Let's first see what we got here. We have r theta over time. So 6 inches, 2,000 pi radians over 60 seconds. Now, if we want to convert this into feet, how are we going to do that? We got to do a little dimensional analysis. So let's see. I need to cancel out inches. What do I know about inches? There's 12 inches in 1 foot. So now I got the whole thing I could type in, and my answer will be in feet per second. So to type that in, got to bring my calculator up, and I will now say 6 times 2,000 pi divided by, now in the denominator you have a multiplication that has to happen, so make sure you put parentheses, 60 times 12. And that gives me 52.36. 52.36, and that's feet per second. So you do need to be careful. If I give you different units, make sure you convert them if you're asked to convert them. Couple more. Ooh, this is cool. The Earth rotates about its axis once every 23 hours. So the fact that we have 3 different units here, hours, minutes, and seconds, means I'm going to convert these to either hours, minutes, or seconds. But if they want me to have it in miles per hour, I'm going to make this all one big thing in hours. But you do need to be careful. We have 23 hours plus 56 minutes is a fraction of an hour. It's 56 minutes of 60 minutes. So you got to be careful there. There's 60 minutes in an hour. We're going to add 56 of those 60. You can't say 0.56. We also have 4 seconds, and there are 60 times 60, 60 minutes and 60 seconds. So that's 3,600 seconds in a minute. So to get my time, I'm going to have to add all that up. So 23 plus 56 out of 60 plus 4 out of 3,600. So my time is 23.934. 23.934. And I'll even put the repeating hours. And the radius of the Earth is 3960 miles. That's cool. Find the linear speed on the equator. So if you're on the farthest out, like that's the radius of the Earth, we're going to find linear speed, so r theta over time. That's the formula we're using. The radius we know is 3960. That's the radius of the Earth. Theta, it's only going around one time. So if it only goes around one time, then it's just going to be 2 pi. Okay, so fine. That's one spin. And the time is, so this is in miles, because remember, we have a distance times radians, so that's the distance is the unit you keep. And the time is what I just figured out, 23.934, and I'll even throw the repeating in there, hours. So this is miles an hour. So how fast are you going if you are just riding along the Earth? 39660 times 2 pi divided by, I'll click that, I went off the round, 1039.56 miles per hour. That's pretty fast. Okay, so this is 1039.5, what did I say? It's 5.6 or 1039.565, so 57 miles per hour. So if you're just riding along the Earth on the outside, on the equator, you're going 1,000 miles an hour. You just don't feel it because you're not accelerating. So that's pretty wild. Last one, wheels of a car have radius 11 and are rotating at 600 RPMs. So theta is 600 RPMs times 2 pi. That's 1,200 pi radians. So if I want to find the speed of the car, that's linear speed, r theta. The radius is 11. Theta is 1,200 pi. And this would be in inches. And my units for time are per minute. But since they want hours, well, I'll just put 1 minute. We'll do some dimensional analysis. So that would be inches a minute, but I'm going to make this thing in miles an hour. So we got to do some dimensional analysis. We got to convert two things. First thing we're going to do is convert inches. I need this to get to miles. So let's see, there are 12 inches in 1 foot. That would cancel out inches. I also need to then get to miles. So there are 5,280, 5 tomato feet in 1 mile. So right now I have miles per minute, but I need to also say I need to cancel out minutes. So I need to know something about minutes. What do I know about minutes? I know that there are 60 minutes in 1 hour. Okay. So now when I type all that in, I will have miles per hour, which is ultimately the goal. But you got to be careful typing it in because it's a lot. So I got to say 11 times 1,200. Nope. It like double taps. 1,200 pi times, what else is in the top? 60 divided by, now I'm going to multiply 12 times 580, but that's got to be in parentheses. So 12 times, or 5280 rather, 5280. So 39.27. 39.27, and this is in miles per hour. So I'll say mph. 39.27 miles per hour. So if you can figure out how fast the wheel's going, you can figure out how fast the car's going. So that's linear and angular speed. You do have a checkpoint. Make sure you get that done. But besides that, the only thing you gotta do is hit like and subscribe.